So we've moored up in Newtown Creek and we've seen a seal, which is very exciting. And we've put the anchor down, but we don't seem to be in any control of the boat, which is quite bizarre. So I'm bobbing around, no idea what's going on, and we're going to make this quite short. But I thought it'd be useful just to talk about the business implications of quantum computing, because it's got quite some dramatic implications. Andy, do you want to just give us a bit of a summary of what you think is going to happen in terms of business implications?
Yeah, so the three main areas that we're seeing for potential for quantum are simulating nature, so computational chemistry that we mentioned before. Then the other kind of big area is optimization. That's a really broad topic. In the financial services sector, we're seeing everything from portfolio optimization to risk assessment. Imagine being able to do intraday or even intra-trade risk assessments of your financial trading position. But anybody who's doing optimization, whether it's cutting shapes out of a pattern, or whether it's optimizing the route that your truck has to take to deliver things, everyone does some kind of optimization. And we're seeing quite a lot of potential for quantum to offer help in those. Not so much solving the big hairy problems, although that's certainly one area, but also getting more optimal solutions quicker. So where you might sort of settle for a 90% accurate one, maybe you get the exact answer. And we're particularly seeing that with things like chemical processes, where you've got making, say, pharmaceutical drugs, where the final yield of your final process could be worth hundreds of thousands of dollars. So if you can improve that by just like 0.01%, then that's a huge financial improvement. The final area that we're seeing potential for quantum is what we're loosely calling unstructured data. So you can think of that as machine learning and AI applications. And what we're seeing there is that training data seems to converge quicker. And when you've got really complicated, tightly folded, high-dimensional problems, they seem to behave better. But it's very early days for that yet, so the jury's still somewhat out.
So in terms of actual sort of business impact, it's changing the nature of the sort of things we can solve with IT. Obviously, we've already touched on things like quantum safe and stuff like that. How profound are those sorts of impacts going to have on businesses? Because it sounds quite scary.
Well, the key thing is that if you are not kind of up to date with quantum now, when that quantum advantage point comes and you actually can do something useful with a quantum computer, then if you don't know what it's all about and start looking around at that point, then your competitors who are looking at it will just be leaving you behind. And that's really the risk, is that although you can't do anything useful with a quantum computer today, you need to be learning about what can be done, looking around your organization for the kind of applications that will be amenable to quantum, and start playing with little problems, little noddy problems, so that when the bigger quantum computers come along and the error correction starts to come along, you can solve much bigger problems, and then we'll cross this quantum advantage point and you'll be able to do something useful with the quantum computing service.
So I suppose, as professionals in today's climate, although it feels like it's a long way away, we talked about early 2030s being the main point at which we get to this quantum advantage, this Y2Q thing. In reality, there are things that we can be doing. And one of the things we spoke about, again off camera, was partnerships with academia and those sorts of things. I mean, how are those sort of things working now?
Yeah, well, because as we've tried to give a glimpse of, this is not easy stuff. What we're finding is that to make a sort of holy triangle between someone with a quantum computer, e.g. IBM, someone with
Other vendors exist, to be clear.
Fair, other vendors exist. A customer with a problem, and academia who can bring the sort of the brain power to creating the algorithm, or taking the building blocks of algorithms that we have today and compositing them together to make a solution for your problem, seems to work really well. And that's how we're seeing a lot of collaboration happening.
So procurement professionals, for instance, could now start thinking about how they're going to build an ecosystem of partners, be they vendors like IBM or local universities and other academic institutions, and smaller sort of specialist companies, to try and engage in the quantum concept, such that in 5-10 years' time they've already got a pre-built ecosystem that they can start using to drive benefit. Is that what?
Exactly, yeah.
Do you see people doing that already?
Yeah, absolutely, yeah. So we've got several hundred members of the IBM Quantum Network, which is companies who are investing in exactly that future. And with although they're they're having to invest now in it was essentially research activity. They're starting to see that on the near horizon there are going to be business results that'll make it all worthwhile.
Okay, so I think I'm just a bit nervous about where I am bobbing around in the middle of this. The anchor doesn't feel like it's working, Andy. Can quantum fix that?
Well, computational fluid dynamics is one that's really interesting for quantum, and we're seeing a lot of problems from weather forecasting to simulating the inside of a nuclear reactor, where just the sheer size of the problem today means you can only get a vague approximation to it, whereas if we get it much more accurate, much quicker on a much bigger problem, then we might be able to get more accurate weather forecast, for example, or indeed work out where the tip of your anchor is dragging.
Yeah, exactly, yeah. So I'm going to call this a day because I'm a bit nervous about it. I will move the boat and then we'll have a chat about something else to do with quantum in a minute.
Perfect.